like to talk to you about smart data. Well, what does that mean, right? Well, I'm going to give you an example and see if it makes sense for you. So we're going to start with a key leader engagement. We have a soft unit who's active in the engagement. Of course, they're interested in everything going on around them. They want to maintain absolute SA for everything they're going to do, especially when they want to leave the place. So what do when they start? They're going to go ahead and, prior to the mission, establish the plan, perform the queries of the knowledge store that we're discussing, find out everything they can find out about that key leader, which, by its inherent nature, will automatically establish alerts for everything it knows about that mission, right? So how does it do that? So what I'm showing you is the guts of a knowledge store. And if you've seen those link analysis tools that exist out there, amazing semblance, right? That's exactly how it's stored inside the system. So what we're looking at here is they established a mission. Within the mission, we had the key leaders, naturally, right? But I've also defined egress and ingress routes. I have the geo descriptions for those. I have the schedule for how the mission should be run. And of course, the named area of interest where all this is going to run in, so we can go ahead and track various pieces of information. So they establish this when they define the mission. So in most systems, that data is either written somewhere or it's in a report somewhere, but certainly a computer's not going to look at that and go, oh, cool, I know what to do with it. Now, I'm going to use the term semantics, and everyone goes, oh, semantics, right? It's always had such a bad name and a good name depending on who you talk to. The only thing you need to understand is a semantic system allows me to model this information in a way that the computer can consider this the same way a human would consider this. So instead of forcing the human to think like a computer, the human enters information just like they would with any conversation. And the computer can understand that model now and say, oh, when you talk about a mission, and you talk about a schedule, and you talk about routes, I understand those concepts, so I can automatically build alerts that might affect those types of things that would impact that mission set. So let's go forward. Where can I actually have threat points, right? If I get any reports on these guys, I might want to know. Could be something very interesting or important. I want to know if any threats, right? I don't care what the threat is. I want to know that there is a threat against the route. I don't have to establish every type of threat, whether it's hostiles in the area, whether it's an IED event going off, whether I just got reports of some IED emplacements just recently. I don't want to define all that in the system. I just want to say threat. And that's the beauty of semantics, is I can define threat as all those, and all the system needs to know is you're interested in a threat, and it'll pick that up automatically. Anything that happens in this area of interest is still of concern because it can impact how quickly I'd have to move through the routes, etc. So all that being said, let's go forward. The schedule allows me to go ahead and define when these things are important. So if you've already run the first phase of the mission, you really don't care much about that ingress route. You're done with it, right? So I don't want to be loaded with a bunch of garbage and alerts that happened after, I've already done with that part of the mission. So the system starts getting smarter and saying, I'm going to inform you with what's important for your mission as is and going forward, where you can actually take action against it. So now we have another unit. Now, the beauty of this is imagine this unit has nothing to do with your unit. It doesn't even know about your mission, right? They're out there doing some active engagements for something they're going to case, or they're just moving through the system to get from point A to point B, and they see some sort of threat. They see some enemy activity they didn't expect, and of course they're going to immediately put together a nice little report. Well, a DIL environment, they might not get the report off immediately. It's actually staged at their system, and anytime the intermittent communication makes a connection, an extremely tiny piece of information flows into the D6 enterprise, if you're familiar with what that is, or just your back-end services, it will actually go ahead and make it to the store. So it itself is also represented in the graph. It has a report, has a location, a time, and what the actual issue is, right? That's great, but now here's where the magic comes in. The semantics picks up on this and says, okay, I understand this is a report, it's detecting a threat. I want to know if there's anything in my system that's currently active that might be impacted by that threat. So we're talking about intelligence potentially impacting a live mission, right? So it goes and looks and says, wow, based on the schedule, this egress route is actually associated with those enemy units in that area. It will actually impact that route. So it goes, well, wait a minute, that egress are associated with that specific mission. So it's going to go ahead and pump an alert, and the alert's going to have its provenance, right? Where did this alert come from? Where did that data come from? How important is that data to me? And so that alert is actually attached to this mission. And what will happen is, again, it's staged. If it can't get to that active mission communications, it'll stage it until it finds a spot, When it actually finds a slot, it'll notify them, right? So once it notifies them, they can go and determine, what am I going to do about this? And obviously, they'll look at it and say, well, if route 1 is compromised, I'm going to go and take egress route 2. So now they get to make decisions based on live data as it comes in through the system, right? So, walked very quickly through a very technical thing, but you get the general idea and the concepts of how information all the way at the edge, if we make it smart, if we give the tags and the elements to it, and we feed it into a knowledge store like I just showed you, that information can impact anybody anywhere in the world that you had no idea even existed or was even active or even in a route or even managing that sort of data. And the system becomes more intelligent because every soldier becomes basically a stream of intelligence that starts feeding the overall intelligence system. And then that can all be managed via the models, the semantics, and the various reporting infrastructures that you stick into the system. So the more that the analysts work with it, the more that the operators are actually going out, the patrol leaders, whatever, as they're interacting with the system, they get the benefit of the models and the understanding of that data, and because it's smart, it knows what to notify them and when to notify them, and hopefully reducing the various false positives and other issues you get associated with this typical raw data search, which gives you everything you didn't want.